Okay, so this Assalamualaikum and good afternoon. So in this live, I'm going to discuss on the we'll do some revision again on the for MAT183, which focuses on the limit continuity and also what we call it as definition of derivative. All right, so let's just proceed to uh, question for October 2018 for test one. Right, so we are given with the limit. Oh, sorry. Mm, we have that limit. All right, question number one. We have the limit as x approaching 0, sine of 2x over x 2 minus cos 3x. Let me stop sharing first. Okay, so we have something like, let's get back to this. Sorry. All right. Okay. So we have this function and we want to find the limits. Of course, when it involves the trigonometry, so we have to use the squeezing theorem. So recall that squeezing theorem says that limit as approaching 0 of sine x over x will be 1. All right, so to do that, our intention is to put this sine of 2x together with x. So how to do that? So let's just make it separately. All right, so meaning to say that limit is approaching 0 of sine of 2x over x, and this whole thing, that one that I highlight in green, will be a 1 over 2 minus cos 3x. All right. Okay, so now I'm going to distribute. I'm going to distribute this limit to these two terms. So I'll have something like limit as x approaching of 0, sine of 2x over x, multiply with the limit as x approaching of 0, 1 over 2 minus cos of 3x. Okay, so we know that our intention is to make to have 2x here, all right, but we have x at the denominator. We cannot take out 2 outside. We cannot, please don't do that. All right, so the only way that we can do is to put 2 in front here, but where does this 2 come from? Actually, we multiply 2 over 2. All right, so when we multiply 2 over 2, right, for this part will be something like Right, I'm going to take out 2 outside here because it's a constant. So it will become 2, and then I'll have the limit as x approaching 0. And then I'll have sine of 2x over that 2 I'll be put here. So 2 together with the 2x together with the x. All right. Sorry. Okay, we'll have something like this. Right. Okay, so now for this part, for the one in blue bracket here, we can try to substitute the value of x to 0. So we'll have something like this one, 1 over 2 minus cos of 0. We know that cos of 0 is actually 1, so 2 minus 1 is actually, right? So this one will become 2, and then we'll have this part will be 1 by squeezing theorem. And then we have that part in the blue bracket will be, right, 1 over 2 minus 1. So this is actually 2 multiplied by 1 multiplied by 1 over 1. So our final answer is actually 2. All right, so this part here, that is the one that we use the squeezing theorem from this to this. All right, something like this. From this to this is the part that we use the squeezing theorem. Okay, so that's this question number 1A. I forgot to put A here. Let's go to question 1B. All right, so we have question 1B. Given that limit as x approaching negative infinity, square root of that x squared plus 3 over 2x minus 1. All right. So we have now the what do we call okay, we have the only the numerator with the square root, so we have to use that modulus of x. All right, so to do this question is to firstly divide with modulus of x on both at both numerator and also denominator. Okay, so we know that for modulus of x is actually given by square root of x squared, and for modulus of x also we have positive x and negative x. This one for x greater than or equal to 0, but this one for x less than 0. So we have something like this now. Okay, and it is important to note that we have negative x is approaching negative infinity in this case. All right, so now in the next step, we have to choose the function based on the one that we've just written just now. All right, so that one, that square root x squared plus 3 will be divided by, all right, this part will be this, right? Because we want to use that square root of x squared now. So this will be transformed into square root of x squared. All right, so this one, the whole thing is divided by, right, that 2x minus 1, put it in bracket. We have to put this in bracket. We should divide with, all right, for this modulus of x at this part, we have to choose either this or this. But now, because it is approaching negative infinity, so this one is approaching negative infinity, we have to choose the negative x in this case. So we have to divide this with negative x. Okay, so we have to simplify this. So limit as x approaching negative infinity of that square root of x squared over x squared plus 3 over x squared. Okay, so everything will be divided by, okay, so we have that 2x will be divided by negative x minus 1 divided by negative x. Okay, so we still have to simplify this. So we have something like limit as x approaching negative infinity of that. Okay, so this part will become 1 plus 3 over x squared. Right, we're done with that part. So now we're going to simplify the one at the denominator. This will be negative 2 plus 1 over x. All right. So now, when we try to substitute the value of x with infinity, so this part will become 0 and this part will become 0 because it has something over x. So we can say that we already obtained 1 plus 0 over negative 2 plus 0. So our final answer will be 1 over negative 2. So this is actually negative 1 over 2. So we are done solving this type of question. All right. Okay, let's proceed to question number 2. All right. So for question number 2, let me just, all right, I want to highlight it here. We have this function defined by this. All right. So let me just zoom out first. All right. Question number 2. We have the function of x given by that. All right. So whenever I get this type of question, I would like to put it in the number line, on the number line, something like this. Right now, we have the negative 2 and 4 on that interval. So for the function which is less than negative 2, we have this, right? So we have that function x squared minus 4 over x plus 2 at the left side of negative 2. In the middle, between the negative 2 and 4, we have the function given by negative 2, 1 minus m of x. And the last one, all right, this part will be for the function greater than 4. So we'll use negative mx to the power of 2. All right. So we know that, okay, we have this type of function. Firstly, we from the piecewise function, we try to put it separately on the intervals like this. And then we try to solve the question. So the question one says that we have to find the value of m so that limit is approaching negative 2 of fx exists, right? So the keywords is that, right, this is for question number 1. Limit as x approaching negative 2 of fx exists. If the limit exists, meaning to say that this is equivalent to saying that limit as x approaching negative 2 from left of fx is equal limit as x approaching negative 2 from right of fx. Hold on a little bit. All right. So you look at the left side of 2. This is 2, negative 2, sorry, negative 2. The left side will be using this function, right? So we have that limit as x approaching negative 2 from left. So we have to use this function. So it's given by x squared minus 4 over x plus 2. And for the right function, we have that limit as x approaching negative 2 from right of fx. So from right of negative 2 is actually this function. So we have to use 1 minus m of x. Okay, so our intention is actually to what do we call it as substitute the value of x with negative 2 in this case, but for the one at the left side, we cannot substitute with negative 2 because it will become 0 over 0 case. So what we need to do is actually we have to do some kind of, when we have 0 over 0 case of the function, we have 3 types of techniques we have to do. The first one is factorization, the second one is conjugate, and the third one will be using the squeezing theorem. But in this case, we can factorize that x squared minus 4. So we'll have something like, all right, so limit as x approaching negative 2 from left of x squared minus 4 will be factorized as x plus 2x minus 2, right? So that one, x plus 2 at the denominator, we are not doing anything. For this part, all right, let's just copy it. All right, let's say we don't do anything on this function, all right? All right, so now we can cancel the function like this. Right now we cancel. So we are left with the limit as x approaching -2 of x minus 2 only. All right, so we have this is equivalent to the limit x approaching -2 from right of 1 minus m of x. Okay, so what we want to do now is to substitute the value of x with the -2. So we note that this x will be -2 and this x will be -2. So we have the -2 minus 2 is equal to 1 minus m. X will be substituted with -2. So now we can simplify this. We have -4 is equal to -2 plus 2m, right? So we have to bring the -2 to the left side. So it will become -4 plus 2. This is equal to 2m. And -4 plus 2 is actually -2 is equal to 2m. So 2m is equal to -2. And finally, we have m is equal to, sorry, m will be equal to -2 divided by 2. So our final answer will be -1. Okay. So we are done with the first part. M is equal to -1. So whenever we already obtain the value of that m is -1, so I'll just rewrite it in the number line, something like this. All right, let's just zoom out. Okay, so I'll just put on a number line like this. So we have -2 and 4. So this part is x squared minus 4 over x plus 2. In the middle, we have 1 minus m of x. So since m is -1, so 1 minus -1 will get 2. All right. So the middle function will be 2x. And then we try to substitute the value of m with -1. In this case, will become +1. So +1x squared. So x squared only. All right. So now we want to determine whether the function is continuous at x is equal to 4. So to check that, we have to check the three conditions for continuity. So the first condition that, all right, this is what we want to check. You don't have to write this, but bear in mind that you have to do this. All right. So to check the continuity at x is equal to 4. So to do this, firstly, we'll have to check if f4 defined. All right, if it is defined, then we have to proceed to second condition, where we have to find the limit as x approaching 4 of fx. So to do this, we have to find limit as x approaching 4 from left of fx, and also limit as x approaching 4 from right of fx. All right. All right. So now and finally, we have to do to check if the limit as x approaching 4 of fx is it equal to the f4. If these three conditions are satisfied, then we can conclude that the function is continuous at x equal to 4. So to do this, let's just find the f4. All right, condition number 1. So I'll just put C1. So we want to find the f4. But f4, which function should we substitute? So look at your, go back to your initial inequality here. So since x is equal to 4 is here, we have to use this function, meaning to say that we have to substitute the value of 4 inside this function. So we have that x squared, so will be 4 squared. So 4 squared is actually 16. So because we get a value here, not infinity or negative infinity, so we can say that fx is defined where at x is equal to 4. Now we go to condition number 2. All right, so for condition number 2, we have that, what do we call, for condition number 2, we have to find the limit as x approaching. Now we want to check the continuity at x equal to 4. So we have to find the limit as x approaching 4 from left, all right, of that function. That function is fx. So you go back to your number line just now. So this is your 4. So which one is the one at the left of 4? Of course, this function, this is at the left of 4, so we have to substitute inside 2x. So this is actually finding the limit as x approaching 4 from left of 2x. Since now it can be substituted directly by 4 for the value of x, so we have 2 multiplied by 4. So 2 multiplied by 4 will get 8. All right, so for the next one, we want to find the limit as x approaching 4 from right of the fx. Okay, from right of fx, you go back to your function. From right of 4, so of course this one is the right of 4, so this is actually given by x squared. So we have the limit as x approaching 4 from right of the x squared is the function. So we try to substitute the value of x with 4. We have 4 squared is given by 16. So check, are the two values equal? This is limit from left and this is limit from right. They are not equal. 8 is not equal to 16. So we can say that, all right, fx, no, we can say that the limit does not exist because the limit from left is not equal to the limit from right. So limit of x approaching 4 of fx does not exist. Does not exist. All right. Since the limit does not exist, meaning to say that, all right, so the limit does not exist. So we should not, we don't have to proceed to condition number 3. So we can directly conclude that fx, therefore, fx is not continuous at x equal to 4. And we are done with question Roman 2. All right. Please take note that we don't have to proceed to condition number 3. All right. Because condition number 2 is already not being satisfied. So you don't have to proceed to condition number 3. Right. You can directly conclude that it is not continuous there. Okay. So now let's just see the last question here. Number 3, suppose we have that, right, the definition of derivative to find the value for this one. So we have the fx is actually square root of 3x plus 2 over 4. All right, so to find this using the definition of derivative, so we have to find the fx plus h first. Fx, okay, I'm gonna zoom in this. Fx plus h is actually given by, all right, at x we substitute with x plus h, so we'll have something like 3x plus h plus 2. All right, so everything should be divided by 4. We can expand this one, right? No worries. We can get 3x plus 3h plus 2. Everything over 4. All right. So to find the f prime of x using the definition, so firstly we'll just write the definition. So you have to memorize this definition. Limit of h approaching 0 of fx plus h minus fx over over h. All right, so this is equivalent to limit as h approaching 0 of 1 over h of fx plus h minus fx. So they are just equal, so maybe I'm going to use the second one. So I'm going to use this one, right, to find the derivative. All right, so this is given by limit as h approaching 0 of 1 over h. So that fx plus h is given by this function. So square root of 3x plus 3h plus 2 divided by 4 minus the square root of 3x plus 2 over 4. All right. So now we have to simplify this, right? Okay. Um, hmm, hmm. How to do this? All right. So firstly, I'm going to simplify by writing that subtraction as a fraction. So it will be something like square root of 3x plus 3h plus 2 minus that square root of 3x plus 2. So everything should be divided by 4, something like this. And then because this is the number, which is a constant, we can take it out from this limit, right? So it will be something like 1 over 4. So we are left with the limit as h approaching 0 of 1 over h, that um, square root of 3x plus 3h plus 2 minus square root of 3x plus 2. The intention is to find the h so that we can cancel h with h from the one in the bracket. So to do that, of course, in this case, we have to multiply with the conjugate of the term inside the bracket. So the conjugate will be, right, so we have to multiply this with, all right, square root of 3x plus 3h plus 2. Because this is minus, so we'll have plus for its conjugate, square root of 3x plus 2. So for the denominator, we just copy the same, everything the same, all right? Plus square root of 3x plus 2, all right? So now, okay, I'll just write 1 over 4 limit as h approaching of 0, 1 over h. Okay, so we'll have something like, we can multiply this part, yeah? All right, so this part with this part. So there is no more square root because that square root multiplied by square root. So we are left with the 3x plus 3h plus 2. And this part with this part. And we have minus in the middle. So we have square root 3x plus 2 multiplied by square root 3x plus 2. We'll get 3x plus 2. But please put that 3x plus 2 in the bracket. Most of the students make mistake when they don't put this bracket here. All right, so please put bracket. So the one at the denominator, I'll just copy it. All right, so it does not involve in that multiplication at all. So that square root of 3x plus 3h plus 2 plus with the square root of 3x plus 2. Okay, so we try to simplify this. So we'll have something like 1 over 4 limit of h approaching 0, 1 over h. All right, so we try to expand the square root, the negative. So we'll get something like at the numerator 3x plus 3h plus 2 minus 3x minus 2. So this whole thing over square root of 3x plus 3h plus 2 plus square root of 3x plus 2. And we try to simplify the denominator. All right, so 3x minus 3x, there'll be no more 3x. Plus 2 minus 2, there will be no more 2. So we are left with the, all right, so 1 over 4 limit as h approaching 0 of 1 over h. So we are left with the 3h, so everything over square root of 3x plus 3h plus 2 plus with the square root of 3x plus 2. All right, so note that we can cancel this h with h. That is our intention actually, to what do you call it, to make that h to cancel that h over there. All right, so now we are left with the, all right, with the part where we have 1 over 4 limit as h approaching 0 of 3 over square root of 3x plus 3h plus 2 plus with the square root of 3x plus 2. All right, so in this part, we only now we can substitute the value of h with 0. So we'll get something like, all right, so when we substitute the value of h with 0, we'll get this part 0. So we have 1 over 4. All right, So that one will be 3 over square root of 3x plus 2 plus square root of 3x plus 2. All right. We know that okay, most of the students have problem to add these two terms. Okay, very simple. It's something like, all right, so suppose we have x plus s, so this will be 2x. What if you have square root of x plus square root of x? Of course, you'll have that 2 square root of x. But in this case now, you have square root of 3x plus 2 plus square root of 3x plus 2. So you'll have, all right, 2 square root of 3x plus 2. Okay, so now we can simplify this. Will become 3 over 8 square root of 3x plus 2. So to check if your working is correct or not, so you can actually try to differentiate this function, right, using whatever technique you have. All right, so let's try to differentiate. So firstly, fx is given by 1 over 4. That's square root of 3x plus 2. I'll put 3x plus 2 to the power of 2, 1 over 2. All right. So when we try to differentiate this, we have to bring down this 1 over 2. So I'll have 1 over 4, 1 over 2. And then I'm going to write this whole thing. So I'll have 3x plus 2. And then that power will minus 1. So 1 over 2 minus 1. Again, we have to differentiate the one in the bracket. The one in the bracket is given by 3x plus 2. So differentiating 3x plus 2 will give us 3. Again, because differentiating 2 will get 0. So we can simplify this. All right, so we'll have something like, I'm going to multiply 3 with 1 over 4 and 1 over 2. I'll get 3 over 8. That green one will be 3x plus 2 to the power of negative 1 over 2. I can write this as 3 over 8, 1 over 3x plus 2 to the power of 1 over 2, no more negative because it goes to the denominator already. So you can change it back to 3 over 8, that's square root 3x plus 2. Is it the same as the final answer? Yes, 3 over 8 square root of 3x over 2. All right. So yes, it's quite challenging doing this type of question, but it's not impossible. You can do this, right? What you need is actually patience. Okay, patience in solving the problems. Okay, so um, let's try to see if I have any other questions. All right, suppose I have this set 2019. Okay, this seems quite interesting. Solving the limit. All right, I'll just do this question quickly. So we have to find the limit. So for question A, I'm doing question 1A. We have that a limit as x approaching positive infinity of x to the power of 3 plus 7x. Everything will be divided by 5x to the power of 3 minus 3x plus 1. So in solving this, different from what we have done in the previous set, for this type of questions, we have to divide with the highest power of x with the highest power that occurs in the denominator. So in this case, the highest power of x that occurs in the denominator is 3. So we have to divide everything with x to the power of 3. So we have something like, all right, so limit as x approaching positive infinity, x to the power of 3 divided by x to the power of 3 plus x divided by x to the power of 3. So this divided by, okay, 5x to the power of 3 over x to the power of 3 minus 3x over x to the power of 3 plus 1 over x to the power of 3. And then we have to simplify it. All right, so we'll have limit as x approaching infinity of x to the power of 3 with x free, we'll get 1, 1 plus 1 over x squared. And then we'll have 5 minus 3 over x squared plus 1 over x to the power of 3. All right. Next is to substitute the value of x with infinity. So when we substitute the value of x with infinity, we'll get this part 0, this part 0, and this part 0. So we are just left with the 1 plus 0 over 5 minus 0 plus 0. So our final answer will be 1 over 5. Very easy. Okay, so for question B, all right, so solving question B, we have the limit as x approaching 9 of 9 minus x over 3 minus square root x. If we try to substitute the value of x with 9, we'll get 0 over 0 case. So to solve this, we have to use the, what do we call it as the conjugate. So we have to multiply with the conjugate of the denominator in this case. So the conjugate is actually 3 plus square root x. Also at the numerator, we'll have to divide with, we have to multiply with 3 plus square root x. So the part that we have to expand is only this part at the denominator. All right. This one you just copy without expanding it. All right. So we'll have something like limit as x approaching 9 of 9 minus x, please put in a bracket, and that 3 plus square root x, put in a bracket. So this part will multiply 3 with 3, we'll get 9. And then we have minus in the middle. We have square root x with square root x, we'll get x. So we know that 9 minus x with 9 minus x can be cancelled because they are the same terms at the denominator and also numerator. So we can write this as limit. Okay, we can simplify this as limit as x approaching 9 of 3 plus square root x. So this is actually 3 plus square root 9. So 3 plus 3, our final answer is actually 6. So we are done. Question B. All right, let's try question C. All right, suppose I have question C here. Limit as x approaching 1 of that sign x minus 1 over x squared minus 1. All right, this is quite interesting. So firstly, bear in mind that this type of question must deal with the squeezing theorem because it involves trigonometric function. So this can be written as limit as x approaching 1 of sine of x minus 1 over that x squared minus 1 is actually x squared minus 1 squared. So this will be simplified as x plus 1, x minus 1. All right. And then we can actually, the intention is to put something like in the form of squeezing theorem given by limit as x approaching 0 of sine of x over x will be equal to 1. So our intention is to put sine of x over x. So in this case, we want to put this sine of x minus 1 with x minus 1, the one that has that x minus 1 there. So we can rewrite this as limit as x approaching 1 of, all right. So I'm going to write 1 over x plus 1 first, all right? And then I'll have that sine of x minus 1 over x minus 1. So then I'll have to distribute this limit. So I'll have something like using the properties of limit, right? All right, so 1 of x plus 1 multiply with the limit as x approaching 1 of that sine of x minus 1 over x minus 1. So this part is actually similar to the squeezing theorem. So the value is actually 1. Why we have that? All right, so if we try to draw that sine of x over x, so the function is approaching 1. So it will be something like this actually. All right, it will be something like this. It does not touch 1, but it's approaching 1. So we shift this graph to the right. Okay, when we have x minus 1, if you have learned this in pre-calculus, but most of you I guess didn't take the pre-calculus, but never mind. If we shift the graph, meaning that, okay, suppose I want to sin x minus 1, x minus 1, so meaning to say that our graph will be something like this. Will be something like this. Because we already shift the graph to the right by minus 1, so this is 1. All right, so if we shift the graph to the left, suppose x plus 1, meaning to say that we shift to the left by 1 unit, so the graph will be something like this. Something like this, all right? So it depends on the equation. So in this case, it's actually shifted to the right. So this is actually using the squeezing theorem also. We'll get 1. For this part, we can substitute the value of x with 1. So we'll have 1 over 1 plus 1 multiplied by 1. All right, so I'll put this in bracket. So this is actually 1 over 2 is the final answer. That? Okay. Let's see some other questions. Set to 2019. Okay, this is quite interesting also. Right. Okay. Solving the limit, right? So limit as x approaching 0 of secant x over 2 cos x over 2 sine x over 2 everything over 2x, right? So we want to find this. If you try to substitute the value of x with 0, we'll get 0 over 0 case. But please look, don't be fooled by the question, all right? This is quite tricky here. Since we have secant function, actually secant, we can transform it to be, right, secant of x over 2, 1 over cos. Secant is actually 1 over cos of x over 2, right? So we can transform it to be, right, limit as x approaching 0 of 1 over cos of x over 2. So we have cos of x over 2 over there, and we have sine of x over 2. So everything should be divided by 2x. Right, let me drink for a while. It's tea life. Okay. Mm, because this is the same term, all right, we can cancel this because it is at the denominator and also numerator. So for this type of question, right, the question is just quite tricky. We have to be careful with the question. Don't be uh, fooled by the question. So we are left with this part. So bear in mind that we want to make the x over 2 in the form of x over 2. So how do we do this in the form of x over 2? If you can't do that, never mind. I'll just put this 2 outside limit. Why? Because it is a constant. So the constant is not involved with the calculation of the limit. So limit as x approaching 0 of sine x over 2, all right, of x. How do we get the x over 2? Of course, we have to multiply by 1 over 2 at the numerator, multiply by 1 over 2 at the denominator. So we have, all right, this 1 over 2 of limit as x approaching 0, sine of x over 2 over, all right, I'm going to bring this together so that I have it in form of x over 2. What about that 1 over 2? 1 over 2, okay, never mind. I'll just put in front here, all right, be something like this. Again, this 1 over 2 is not involved with the calculation of the limit. I can put it outside because it is just a coefficient. So this will become 1 over 2 multiplied by 1 over 2. So we have limit as x approaching 0 of sine of x over 2, everything over x over 2. So it is obvious that this is using squeezing theorem and the value is actually 1. So we'll get 1 over 4 multiplied by 1. How to get this one? By using squeezing theorem. So our final answer is actually 1 over 4. Okay, for this part, all right. Question, it's one question A. Let's get to question B. Very challenging. Yes, very challenging. Inshallah, a lot of exercises. If you have done, you'll be good doing the solving the problems. Okay, we have this limit as x approaching negative infinity of that. Hmm, saya lah ni buat soalan ni. Apa soalan ni? 5x to the power of 3 minus 8x to the power of 5. Everything 27x kuasa 5 tambah 4x kuasa 4 adalah x kuasa 2 tambah 2. So we have that 1 over 3 here. Students, when they see this power in fraction, they will be very panic. It's nothing actually. You just transform it to be cube root or square root, all right? So we have this. All right, I'll just rewrite this as limits as approaching negative infinity. Because it is 1 over 3 here, will be cube root. Cube root of what? Cube root of this 1 plus 3x squared. All right, I'm going to zoom this. Plus 5x to the power of 3 minus 8x to the power of 5. Everything over 27x to the power of 5 plus 4x to the power of 4 minus x squared plus 2. So this is the same as solving the limit as x approaching infinity without that square root actually. Alright, anggap sahaja square root, cube root ini pengganggu sahaja. What you have to do is to focus on the highest power of x that occurs in the denominator. Which one? Of course, x to the power of 5. You have to divide everything with x to the power of 5. So in this case, we have the limit as x approaching negative infinity, right? Of cube root. All right, so I'm going to take that this one, we have to divide with x to the power of 5. Next, this one, plus 3x squared, divide with x to the power of 5. Next, this one, plus 3x cubed, 5x cubed, be careful, 5x cubed over x to the power of 5. Next, minus 8x to the power of 5 over x to the power of 5. Okay, at the numerator, I'll have that 27x to the power of 5 over x to the power of 5 plus 4x to the power of 4 over x to the power of 5 minus x squared over x to the power of 5 plus 2 over x to the power of 5. And then we have to simplify this, right? So we'll have something like limit as x approaching negative infinity of that cube root of 1 over x to the power of 5 plus 3 over x to the power of 3 plus 3 over x to the power of 2. Why is it 3? Why always I write 3? It's 5, all right? Maybe I'm very obsessed with 3. Minus 8, because we already canceled this x5, x5. This one also can be cancelled here. So we have, all right, 27 plus 4 over x minus 1 over x to the power of 3 plus 2 over x to the power of 5. Next is the part that we have to substitute the value of x with negative infinity. Substituting this part will become 0, this part becomes 0, this part will become 0. Because anything divided by infinity will get 0. So this part will become 0, this part will become 0, this part will become 0. So we are only left with negative 8 over 27. So this is actually cube root. Be careful, we still have that cube root, negative 8 over 27. Pressing our calculator, solving this, we'll get negative 2 over 3. So that is our final answer for this one. All right, it's not that difficult. It's just that the equation is quite tricky. All right. So this part, I guess that's it for this afternoon's live. I wish you all the best. Uh, look back your tutorials, all right? Do look at your how you do the differentiation. Sorry, the find the limits when it involves the square root and when it involves the conjugate, when it involves the factorization. You look back, and then inshallah you can do it. All right, so that's it for today. Thank you for watching.